everyone, it's Alyssa and welcome to You Can Learn Math. So today's lesson is the first part of 3 talking about systems of equations. This one is going to be about substitution, part 2 is going to be about elimination, and part 3 is graphing. So if you need either of those 2 ways specifically, please go to the description below. I have the links down there for parts 2 and 3. This one, part 1, again, is about substitution. So let's look at, well, first, what is a system of equations? What is it? Okay, let's see. What if I did, okay, I'm just going to, let's pick some numbers. What would that be equal to? Let's see if I did that right in my head real quickly. I hope so. This is what happens when you don't prepare, kids. So this is a system of equations. What we're talking about is a real world equivalent of this, I should say, would be if someone was telling you a math riddle, because why not? Why wouldn't one of your friends just be telling you math riddles on a Friday night? And they said, I have this charming riddle for you. I have 2 numbers I'm thinking of, and when I add them together, I get 12. If I multiply the first one by 2 and the second number by 3 and add them together, I get 27. What numbers am I thinking of? And you probably wouldn't answer them but leave and go like, dude, really? But just for the sake of argument, let's pretend you found this just fascinating and you're like, yes, I want to figure out your math riddle, random friend of mine. And so you have these 2 equations, and that's the representation. I have 2 numbers that add up to 12. If I multiply the first one by 2 and the second one by 3, I get 27. Sorry, I'm trying so hard. There's so much pollen in the air where I'm at right now. I'm trying so hard not to cough. It is a losing battle I am fighting here. I think I'm going to have to just pause for a second. Okay, let's see if I manage to cough enough to get rid of that feeling. So, substitution. Well, you think of substitution, relate it to a word. If you're trying to remember on a test when it says solve by substitution, you're like, which way was that again? Think of it like it's close word in English, substitute. I mean, if you have, you have your regular teacher and they are out for the day, you have a substitute teacher. They are an equivalent teacher. They're taking the place of the teacher. They look a little different, but they are taking on the same role as the teacher, and they are both doing the same job for that day. Essentially, I know it's not quite that straightforward, but you know what I mean. So that's what we're going to be doing. We're going to be taking some terms and substituting them for other terms to solve. Well, first, I'm going to get x by itself. I'm going to solve for x when I look at this. I'm like, I think that's going to be the easiest. I can pick either one, solve for x or solve for y, but I'm going to solve for x. Now, if this was with real numbers, or if y was a given number, like x plus 7 equals 12, how would I solve for x? I'll go, okay, well, 7 was added to x, so I need to undo that by subtracting 7. And in algebra, if there's an equals, I have to do the same thing on both sides to keep it balanced. So I'm going to subtract 7 from both sides. X equals 5. Well, let's say if I wrote this out, instead of writing x equals 5, what if I wrote this out? X equals 12 minus 7. That's true, right? I mean, that's what I did. X equals 12 minus 7. So that's what I'm going to be doing over here, except instead of 7, it's going to be y. So x plus y equals 12. I subtract y from both sides. X equals 12 minus y. Same difference, same process. And you're probably sitting there going, okay, well, that doesn't really tell me anything, but cool, I guess. It does tell us things, and you'll get that much closer to answering your annoying friend with his math riddle. So x equals 12 minus y. The whole goal for substitution and for elimination, we are trying to take one of these equations, either one, and we're trying to get rid of one of the variables in it so that we have an equation with just one variable. Because if I have just one variable, like say if this was 2x plus 15 equals 27, it's like, cool, I got that. I can do that. I subtract the 15, I divide by 2, boom, solved for x, and I'm good. Well, if I have two variables, there's no way. There's no possible way of knowing what they are with just that equation. If I was given just that and said, what's x and what's y? I don't know. You can never know because x could be 1. Okay? And then 3 would be, what is that? 8 1/3, I think, off the top of my head. I'll have to double check that. Or x could be 2, in which case this would be now 3, y would be 7 2/3. That could be anything. There's all these different combinations and possibilities. So no, I need one variable in here, just one, and then we're talking. So how do I do that? Well, I know that x equals 12 minus y. They are the same. That is what equals means. These things are the same. So I can take this, I can take this and plug this in for x. So that's what I'm going to do. I'm going to say 2 times, and instead of writing x, I'm going to write 12 minus y because they're the same. Plus 3y equals 27. Nothing else changes. That's all I did was I took 12 minus y and put it in for x. All right, so let's scoot up a little bit here. Okay, so now I'm going to distribute. 2 times 12 is 24. 2 times negative y, negative 2y, plus 3y equals 27. Now I can combine these like terms right here. And that gives me, next line, 24 plus y equals 27. Now, even simpler, y plus 24 equals 27. I'm going to subtract 24 from both sides to solve for y. Y equals 3. Okay, now I know y equals 3. Yes. And I tell my annoying friend, I know your second number, it's 3. And he goes, but you don't know the first number. Well, I'm about to, because x plus y equals 12. If y equals 3, I erase. X plus 3 equals 12. Well, then I can subtract 3 from both sides. And, because I'm running out of room, should have planned this better, shouldn't I? X equals 9. So I now know, and this is special enough, I'm going to write it in multicolor. X equals 9 and y equals 3. Now let's see if this actually is the truth. I'm going to erase some of this so I can get a better look at what's going on, so it's just not cluttering my screen with all this stuff going on. Here we go. Okay, let's plug these numbers back in and see if it works. First, 9 plus 3 equals 12. Is that true? Why, yes it is. And our second one, 2 times x plus 3 times y equals 27. Okay, 2 times 9 plus 3 times 3 equals 27. 2 times 9 is 18. 3 times 3 is 9. 18 plus 9 equals 27. We have a winner. And we can tell this to our annoying math friend, and hopefully he will find a different hobby that he can harass us with when he's talking. So this is the substitution method. Even if we don't have something as simple as this, where x plus y equals 12, we can still use it. We can still make it work. You just have to solve for an x or a y. And actually, just really quickly, I do think it'd probably be beneficial just to show you how this would still work even if I solved for y. So let's do that. I'm going to go through it pretty quickly. All right, so same thing. X plus y equals 12. I solve for y by subtracting x from both sides. Y equals 12 minus x. So now I'm going to take that and I'm going to substitute it for y. So that becomes 2x plus 3 times, not y anymore, 12 minus x equals 27. So, oh, let's erase all that down there. Messy, messy whiteboard. Okay, so then next step, I'm going to distribute. So I'm going to get 36 minus 3x. I'm going to bring down that 2x too. Also, 2x also. Okay, so now I can combine like terms with the 2x and the minus 3x. So that's negative x plus 36 equals 27. Then I'm going to solve for x first by subtracting 36 from both sides. And I get negative x equals negative 9. Then to get rid of that negative, I'm going to multiply both sides by negative 1. And that gives me x equals 9. And then I go back up to the top and I would say x plus y equals 12. 9 plus y equals 12. Subtract 9 from both sides, y equals 3. Same exact answer. Many times in math this is true. You can do something 2 or 3 even different ways and still get the same answer. Sometimes it's just about what makes the most sense to you. If solving for x makes more sense, do that. If solving for y makes more sense, do that. The one caveat I always put on this is if you are in a math class and are not just learning this for your own personal use, please follow whatever directions your teacher or the test or worksheet you are working on give you. If they say specifically, solve for x and use that in your substitution, please do that. If it's up to you, then do what you want. But if you are in that class, please do not get points taken off by doing things a different way. So that's just a bit of life advice, is always follow the directions when it's for points. And as a brief sort of aside, this will work even if it's something like let's just say if it was like 3x plus 5y equals, I am so making this up, equals 50, and 4x minus y equals 22. Or even just making like 2y equals 22. You can still do substitution. It's just a little extra step. Like for instance, that 3x plus 5y equals 50. If you solve for x, and you can use either equation, I should say that. You don't have to use the top one and solve for x or y. You could use the bottom one and solve for x or y. It's whichever one makes the most sense you can use when you're doing substitution. So for instance, this one, 3x plus 5y. Okay, I'm going to subtract 5y from both sides. 3x equals 50 minus 5y. And then I would divide everything by 3 to get x. Not as pretty as the last one. And for some reason, my mouse is making this jump around. But that's it. That would work. That would still give you the same answer. So it doesn't have to be, you don't have to be given like a simple x plus y equals something. It can be this more complicated and it will still work. And even in that last one, you didn't necessarily have to use x plus y. You could have used the bottom equation. It still would have worked. Okay, if you have any questions about any of this, please leave them in the comments below, but that's an overview of substitution to get you started on that. Again, part 2 is going to be about elimination for solving systems of equations, and part 3 is graphing. Links in the descriptions below. If you like this video and found it helpful, please like. If you'd like to see more like this, please subscribe. And any suggestions you have for future videos I'm trying to go through step by step, which is going to take time, but all the different concepts in algebra, geometry, trig, calculus, you name it. I'm trying to go through everything. But if there's something specific that you'd like to see before I get that far, please let me know and I'll do my best to get to it. All right, thanks so much for watching. Hope you have a great day. See ya.